Congratulations on reaching this stage of the course. By now, you've learned how to write code in Python and have grasped some of the fundamentals you'd need when investing on the stock exchange. Do you feel good about what you have learned? You should, as you now know about rates of return of a stock, portfolio return, volatility, covariance, and correlation. These are all fundamental concepts in the world of finance. Starting from this lesson, we'll continue to dig deeper and learn more advanced techniques for financial analysis. Okay, perfect. Let's start with regression analysis then. There are people who devote their lives to this topic. Many econometric and statistical models use this concept. To respond to this, in Python, there are modules that help you run a huge variety of regressions. Here, we will learn about one of the most widely used types of regressions, the OLS regression. First, we are going to import a couple of modules we haven't used so far, stats from SciPy and statsmodels.api. API is a suffix indicating we will import a large part of the stats models module. We will use the typical abbreviation SM for shorter. Good. After we have done that, we can load some housing data. It is information for 20 observations only. We have the size and price of houses, the state they are located in, the number of rooms that they have, and the year when they were constructed. Briefly, our first goal will be to regress a house's size on its price. In the previous lesson, we introduced the concept of univariate regressions. To run such a regression and explain the dependent variable house price, we will need only one independent variable, size. Hence, it will be convenient for us to focus on a table with only two columns, referring to a house's price and its size respectively. We can use the names of the columns of interest and type them in with double brackets, which will lead us to the desired output. Great! Python allows us to follow a very intuitive procedure for running a regression. We assign the data in the house size column to a variable we will call x. This information will stand for independent variable. Instead, y will refer to the house price data. Okay, let's check what we have got here. A couple of objects containing 20 elements each. These are the values stored in the x variable. While here, we have the house prices of each observation. Perfect! Matplotlib helps us project our data in a graph. Let's use the scatter plot. All data points will be scattered in this chart. This point, for instance, will refer to a house that has a size of 1,400 square feet approximately, and to a price of $820,000. That point instead corresponds to a house that has a size of 1,600 square feet and that has a price of $1,100,000. You see? This is how we can interpret the position of any of the 20 points we see in the graph. Is there anything we should be careful about? Yes, I am extremely cautious about one aspect. Let me tell you. Presented this way, the chart may delude the reader. The reader might think this house here is ridiculously small and doesn't cost much, while that one in the other corner is super expensive and huge. If you pay close attention to the numbers shown along the axes, you may then understand there is something wrong. Therefore, the first piece of advice I would like to give you is that the axis method allows you to set the start and the end values of the axes in the following way. Start and end value of the x-axis, the horizontal axis, the one of the independent variable, and then start and end value of the y-axis, the vertical axis, the one of the dependent variable. I know that in this sample, we don't have a house that is bigger than 2,500 square feet or more expensive than $1.5 million. So 0, 2,500, 0, and 1.5 million will adjust the graph accordingly and provide us with enough space so we can plot our observations. Lovely. I hope you agree the picture looks much better now. We can see that even the smallest of the houses in our sample costs a lot of money, and we can get a better idea about the size-to-price ratio of our data. There is a little extra improvement that we can add to this graph. I would like to emphasize that when creating a professional graph, practitioners prefer to label the axes. plt.ylabel will add a label along the y-axis, and plt.xlabel will place a specified block of text below the x-axis. Thus, even if you had made no prior analysis of the data, a graph could tell you a lot. Do you agree? You can immediately understand it represents a relation between the size of a house and its price. Creating a good visual representation of a dataset is worth more than 1,000 complex calculations in certain situations. For this reason, we devoted more time to showing you how to improve a chart. In our next video, we will run a regression in Python. See you there.